and then zero slope is horizontal. Okay, so let's look at some examples. Now, I'm going to try this, and again, quite confident that it's going to work, although I never have done it. So let's do that, and let's do that. So theoretically, you should be able to see a web page. Now, this web page, and I'll give you the link to it so you can practice this if you want to. I'm going to click on New Plots. Okay? And you can see, hopefully, that I got these different plots. This one looks like it goes up. This one looks like there's not a whole lot there. This one goes up, and this one's negative. A pretty strong negative. So what it wants us to do, and again, hopefully you can see these, is that it wants, the game is to see if we can determine which one of these is which. So, well, this one has got a pretty strong negative relationship, a minus 0.84. So I believe that's going to be plot D. This one is pretty close to 0, a minus 0.14. So I'm going to say that that's plot B. Okay, and now this is sort of going to be interesting because I've got R is equal to 0.72 and R is equal to 0.77. So which one of these do you think is the tightest one? Which one of these do you think has got it slightly better? Well, because of these endpoints separated out here, and this does look like it's got less variability than plot C, I'm going to guess, and it's about a 60-40 guess, I think, that this is going to be plot A, and plot C, I think, is going to be this one over here. So I've got a choice for B, a D, choice for B, choice for C, choice for A. Let's see if, click on the answers, and let me see what I got. Okay, hey, I did pretty good. Got 4 correct out of 4 plots. Okay, so let me try again. Let me get some new plots. Okay, negative, negative, negative. All these look like they're negative. This one is a little bit positive, so that makes it pretty easy, so I'm going to say that it's A. And look at this. I'm so lucky today. The difference between 0.54 and 0.51. How am I going to do that? It's just going to be a guess, guys. So this one's pretty tight, almost in a line, so I'm pretty confident that's going to be C. And, goodness, this one's sort of all there together, and this one's scattered out, but it's got some points on the ends here. I don't know. Just to go ahead and pick one, I'm going to say that D is a little bit better than B. Although, if I'm wrong on this, I wouldn't be surprised. Well, I was wrong, right? Because I got 6 out of the 8 plots. Quite honestly, on a test, I'm not going to hopefully give you anything that is this close. Those would be hard to guess if you didn't have the original data. And I guessed wrong on those. So anyway, so this is a fun little game, and you can actually use that to help you to look at a plot and then get some sort of idea about how much predictability you might have in that. Okay? So, let me go back over to here. And here is the link to this location. http:// www.stat.uiuc.edu/courses/stat100/java/GCA, and it will be important here to use caps. Capital G, capital C, capital A, applet, capital G, capital C, capital A, PPLET, capital F, RAME, .html. And I will put that link in the Moodle information so that you don't have to write that down just exactly, so that you can just click on it and go to it. There also is another one that we'll look at in a minute, and I'll put it also in the Moodle information so you can just go and click on those. I do encourage you to go through and play around with those and see how they work. It will help you with your understanding of this information. I encourage you to go there and try some of those, see how those work for you, and just practice some of those. Let me, okay, now show you the table in the book that we'll use to go through and determine the significance of these. This is the Pearson critical values, the Pearson correlation in the textbook. So N is going to be the number that you have for your in your sample. You see it starts at 4, and then for alpha equals to 5, it has to have a R value of 0.95 or greater to be significant. With 4, you have to have almost perfect line. Understand that if you only have 2 points, on your graph, you're going to have an R is equal to 1. Or if it's negative, you change colors, I guess. If it's negative, then there's going to be an R is equal to a -1. So a situation where you have just 2 points, it's not going to give you a whole lot of information, but the R value is always going to be significant there, or always going to be perfect in that situation. Okay, that concludes the second session. I'm going to leave you for just a minute or two, and then we'll get started with the third session.